Now let's talk about the database stuff, because this is where it gets really interesting. In the old version of the code, only thing the database did was just get data and put it into the game. Just, no ifs, ands, or buts. There was not really any kind of conditionalizing based on IDs that you'd want to have. It's just either you got a single ID or everything from the database shoved into your face and pushed into your ears or your eyes or whatever by the code. Now in this one though, I want to say, okay, that's fine and good, but we want to make this version a little bit more sophisticated, and we need to have some way of like filtering on menus and things, so that like if the player only wants to see certain types of weapons that maybe would work on a frigate, or if they want to find get a list of the different CPUs based on their processing power, or they wanted to limit their available engine list by a maximum amount of power required. They should be able to make these choices and have the lists update based on that, so that they can see things in a way that they want to, or make it easier for them to go through things. So I kind of had to try and figure out how I was going to do this. I mean, the first part about just bringing the data in, that's fine. I wanted to, basically duplicate what was already in the database and data system classes from the old code. We'll get to that. And then add in this other functionality. So the first thing I wanted to do was to get rid of the two classes and make them one, because I was tired of having to modify both classes at the same time, and it's really confusing and difficult to deal with linking those into other classes. As then you had to have a reference to the data system class, and then you would call the data system class, and then that you'd have to call the database class a couple times. It was just really a mess. So I said, okay, we're going to figure out a way to combine these, and that's what I did. So there are two different phases to this class. The first phase sets up the query. The second phase does the query, and actually three. And the third phase allows you to return the data from the query to the class that's asking for it. And you do this with only two function calls, as opposed to from the external class, as opposed to two from the external class, and then I think three from the main data system class. And we're also doing it in a way that's much less code intensive than before. So let me go show you how the code worked before. Data system. So, like for example, we had this here. Here's a perfect example here. So our DSAR data. So this is the asteroid instance of data system. Our data is basically the class that every function every class will call to set up a particular query on a table. So or select from AID. So we're selecting a particular OR ID and we're looking for it in the database. So if we go to that definition, I don't want to go to peek. I want to go to goto. So in here we have a string table, string operation, and ID. So what we're doing now is you can ignore this bit because that shouldn't even be there. I'm not sure why it is there. The OpenDB part's fine, but the other two aren't. So they're basically recreated for each one of these if statements. I have no clue why. I don't know. Probably because eventually I decided that the table names are not going to be table names. They're going to be just like like ship instead of ships, a weapon instead of weapons. I don't know why I decided that, but that's how I decided to do it. Which caused it to be more code, but a lot of this version of the code is like that. So we have this. We create the set the table that we're going to be accessing in the database instance. We create the statement in the database instance. We check to see if the data system ship vector has anything in it. And if it does, we clear it because we don't want to pollute the return data with old return data. And then we call this get S results from the data system, and we pass it B errors, because if there's an error, we want to get it back. I'm not sure why we're returning it here. There's probably actually something down here that will process those errors. If not, then it was something that I had planned to do and never got around to, or just was like that. Okay, yeah, DB closed. No, it's the same thing. B errors. I don't know. It's used somewhere for something, but I have no clue what. And then we get the return S result. So we're passing through ships. And this turns out to be a reference on this over here. So it's an AND. So passing a reference to update it over there, so we don't have to update it over here. So if we go to table access, we'll just go over there and say we're just basically just a one-line thing to set the D table variable over there. This creates the statement. So we're just basically creating the statement. We've got a string stream. We are using it to convert the int ID into a string. We then look at the operation, select from ID is equal to is greater than 0. So we're saying select all from table where ID is the ID, or if it's a 0 on the ID, then we're just getting every record from the table. Next, we then call get us results, which is the function which is querying the actual data. I hit peek again. So we're just going through and saying, okay, we have this query that we're preparing, we're running through it. As long as the results SQLite row, do this stuff. And then we're doing that stuff. And we're getting all the information, putting into the results, and then returning to that, and then calling the return as result, which is basically setting all the variables to this individually, so that when we clear this out, it doesn't cause any kind of problems with wiping out data. And then we clear the S results vector from the database class to reuse it later. Then, in the class that you were in before all this craziness happens, you then have to call another class to get that information. So in this case, we're calling the get OB size, so get or base size, to set the temp value, so the base size for the asteroid where it starts at. And then we're using these other ones to get the other information from there as well. And so it's kind of a really crazy process, and it's very kind of complex and a lot of places for failure. So let's do the same thing now for asteroid built in this class. We'll just walk you through it here. So we come down here. So we are looking for a particular type of ore that has a specific tier and specific stage value. So we just want to get these types of ores that we're going to use for this particular asteroid. So we call DSAB prep query. We're passing through the table, we're passing through select from where is the operation, passing through 0 since we want all the records that match the conditions, and we're passing through the conditions. So that will go to one of these three prep query functions based on the parameters. It'll basically be like an override essentially. So if we're doing a range instead of an int, we'll go for this one. It'll go to this one. If it's a vector instead of an int or a range, it'll go to this one. Same thing with build statement. So the first thing we do in here is we take the table and we're setting it to SQL table. Then we're building the statement down here, and here's where some of the magic happens. So first thing I decided to do was to say screw off to the string stream and use toString now that it's available in C++ 11. The other code was originally coded in 2013, so that's why that wasn't there. And I think even in it was the version of 2013. I think it was still C++ 11, but didn't have access to toString for some reason. I think, or maybe it wasn't C++. I'm pretty sure it was C++ 11 capable. 13 was. So then we look at the operation. So if the operation is select from and the ID is greater than 0, we basically do the same thing. We just set up the select all from table where ID equals the ID, and then set rows to 1 since we're only returning one row and we're only expecting one row to be returned. Next, if the select from is if the ID is 0 for select from, then we want to do select all from table, then rows -1, so we can get this so we get the number of rows later on in some other code. We have this set to -1, so it'll trip that code. Now the newest part in addition to this in this version of the code is this next one where we're doing select from where. So basically now we're allowing the code to build a where condition list, if you will. So we're getting where conditions in a string vector, and if that vector has something in it, we are processing through here. So where condition string is being set to where, and then for each condition in the string, we are adding it to the wherecon's string here, and putting an and in there, and then concatenating it all together. So select all from table where conditions, and then again setting rows to -1 because the ID is 0 and probably will always be 0. Should always be 0 for this. And then we are casting the SQL string to a SQL statement object. Next we call query data, which is this is basically the R data class, except it's much more streamlined. Because since everything's already set up, all we have to do is call the return functions now. So in this case, we'll say we're doing settings. Just kind of bookended here, the settings namespace. So if the table is settings, we call return set. And return set, we clear the vector that the results will be stored in. We then add the new instances of struct setting to that results vector. And then for each one of those instances in result settings, we are looping through and running this code. So first first of all, we're doing a statement prep here. So one of the things that used up quite a few lines of code in the other code was that we were using this code, or most of it anyway, and every return function, this prepare statement code, and then the resulting error handling because of that as well. So instead I decided, okay, we'll move this over to its own function, and we'll just be able to update the statement that way. We'll return the statement once it's been prepared, and then pass that through to the proc step, so I can do SQLite 3 step on it. Yeah, actually those settings. So if the statement is properly prepared and there's no errors, this will be false, otherwise it'll be true and it won't continue. The other thing that happens then is we look at the rows. If the rows are -1, then in this class we go to get return rows, run some code, and we get the number of rows back. So that we know how many rows to process through how many rows that we need to have, not rows, how many instances of a particular struct we need for that query, so that we can have enough structs to fill it properly. And then we go through here, and assuming that all works, we go down to here, and we, for each instance of struct setting, we are running proc steps, so we're basically just iterating over the rows that are queried. And then we call another function that will actually set the columns on these other functions. It doesn't do it on this one because there's only 2, but like on this one up here, you have get return calls, just a number of columns, and then we go to this get whatever the struct type is data. So in this case, weapon targeting systems data. And so this comes down to here, and basically just do this thing down here because it's easier that way. Keeps those functions up there less large. Doesn't make them really huge and difficult to get through and kind of debug. But also before I combined the singleton and the vector returns, vector queries. So before I had two different versions of these queries, one where you would return one element and then one where you would return a vector of them with the queries to the database. And instead of doing that, I decided everything will run through the ones with the vectors. Then we'll just return one element of the vector if we're just looking for a singleton object later on. So, and then that's how this came into being here. So both those two different methods, different functions, would then call this particular one to set the information for one individual element of the struct instance that they were dealing with, either as a vector or as a single struct instance. And then I wouldn't have to duplicate this code elsewhere in various places. So you just get the information, and this really is, I don't know, this could cause not problems, but be really annoying at times because every time you're going through this, it's going to call this because, well, not every time, but there will be some times when it happens if you're not pulling in certain types of data. For example, in case of the modules in the inventory in the equipment table, there will be certain values that will be used by them and some that won't. So there will be cases that will be missing from the case list because those fields aren't used for that particular item. And so every time you run into that situation, anytime you don't get that case value in there, but it iterates over the value, it'll throw this warning message, which is why I added in a setting to for the player to be able to set the verbosity of this debugging, this logging system. So there's a new new setting that you can set to 1, 2, or 3, and depending on that value, you'll get only errors. You get errors and warnings, or errors, warnings, and information in the debug log file. So once all that is done, it goes through and it just does a finalize on the statement, and then that ends what this does. Then you need to call the get value. So we want to get the particular data that we return from the database. In this case, we're returning a vector, so we're calling get resources, and we're returning that results vector. If we're just looking for one resource, we'd call get resource, and we'd just return the first element of the vector, because that's all that would be filled. Again, I figured that we should do it this way because it's a lot cleaner looking, since there's only one line. Sometimes it makes it a little harder to go through and look at it because you have to kind of really look at each one, and sometimes you kind of get distracted by this other stuff, or you miss something somewhere. But it is a manageable trade-off to have it look like this, a lot more compact, a lot more clean looking, and also to reduce the number of lines of code. Now here you can see how we build the map. So initially the map is nothing. The map is built from a result sets vector of struct setting instances, and we take the pair. It's actually or we make a pair using the key and the S key and S val from that struct, and then put it into the return settings map. Return that map to the calling function, and then pass that into the settings namespace. So the total number of lines of code in here is, I think, just over 2,000. Just over 3,000, almost 3,200 almost. I still don't have everything in here yet, and I don't have any of the loading or saving code yet. But even with that missing, the total number of lines of code in the data system and database classes combined in the old code is about 9,000 or so. So we've got about 2/3 less code so far than that combination of classes from the old code. So that's going to be very interesting to see how much reduction we can get from the other stuff. And we may end up having a very much smaller file compared to the other two because of how the loading and saving code is structured and ways that I can try and figure out how to reduce that. And I'll show you what I mean by that. Database. Let's do this to be faster. So as you can see here, we have this crazy prepare statement, and to be honest, we don't really need this. I just thought, hey, it'll be cool to do this and make it parameterized, yeah, because that's awesome and it's injection proof, and I don't know, people will be injecting things into their own games to break it or something. I have no clue why I did it this way, but I did it this way. And you could just simply do this by insert into player data the field list, then values, and just do a value whatever values, and then a list of these here somehow. Throw a for loop or something and have the same effect, and not have to do this because this is like nightmarish stuff. Because you have to have a variable to handle each individual type of data that you're putting into here. So in this case, it's mostly integers. So you have to have one integer variable to store the value, to bind it, and then to insert it. So you end up with like dozens and dozens of variables that you're using. Instead, what we could just do is to say, okay, build a, say we have a, so like this, for example, is a total of, well, we'll leave that there. Pair v2. So this stuff basically, let's see, that's line 4840 to line 4091, so 51 lines of code there. We could take this down to maybe 1 or 2 lines by having this, then doing a for loop and saying, okay, we have this values, now we want to do this part. And each of these will then be a variable, obviously. But we would loop through the object that we're trying to save. So since this is the player data, I think since it's player data, we only have one of them. So but let's say we have multiple players for some reason, just for the hell of it. So this is not going to be code that's the compiler is going to like not be complaining about, but we'll deal with it. So for like, so it's an entity, so entity player in game ents or something. Assuming game ents is a entity, a vector of entities. And then we would say, for each one of these, then we want to say, so we'd have SQL str, which would be up to values up here. So when you're looking at this, up to values is where we'd be at. This other stuff at the end of it, you can see here on the edge, wouldn't be there. It'd just be values, quote, semicolon. So we'd say that plus equals, and then we'd have one of these for each of these. So plus equals, then we do a plus, then we do the ID, so it would be ply dot get ID, assuming that the player has an ID, which they should. So you would create that ID on creation of the entity object instance. Then we would have this, or a plus, and this, then a comma, then the name. So we'd then also have a single quote for the name. So then ply.getName. plus. Then the rank, which would also be a string. Then CXP level, which is an int, so we just leave that there, plus ply.get CE level. So get plants destroyed, so get pdest, I guess. There's no function for that in this code, but just assume it's there for the moment, and that's on a red line of doom underneath that. Then next you have all the different kills and so on and so forth. So you get the idea, you have that. So bring this down so we kind of have something a little more to work with. So then plus, so I want to retype things. ply.get fkills. And you can't get the idea. So you'd have this, then would go to the end, let's put ... there. Then you go to the end, and you would have at the end a comma. And then you would have some sort of conditionals, or somehow you would get to the last element somehow, or maybe after you're done with this, get the very last character and switch it out for a semicolon. So instead of doing all this down here, you literally just do this. So you take all that and turn it to one line. And that's how I would and will create it over there. So this could be a lot smaller eventually. So it'll be very interesting to see how that all works. All right, I'm going to take a short break, and when we come back, we're going to go talk about some other coding. For the new version of the tool. We're already at an hour and a half, but that's just how it's going to go. Nothing I do with these developer vlogs is ever short. You cannot criticize me for making videos that are too short. That never happens. When I say it's short break, I meant a short break. That's basically when crap, excuse me. When I got a cough drop because my throat's getting really fracked up from all the talking. It was actually kind of sore when I got up this morning anyway, so aggravating it now, but Scalp Trip hopefully will help keep things a little less raspy. Alright, so I mentioned the modding tool earlier. We're going to go and take a look at that now, and I'm going to show you what I have so far for that. So I've been working on that recently. I actually started working on it last night. And this is what I have so far for it. It's pretty basic. It does some things, but not others. Eventually it'll do a lot more. For now it's doing just some really basic stuff. So I'll just show it to you, and then we'll kind of look at the code for it. Eventually I'll figure out a way that this can just go away when we click on OK. But this is just like a welcome screen. Tells you about the version and some of the key features of it. So how this is going to work is eventually what you'll have to do is we'll click on OK. It'll bring up this window. You'll need to go to Tools and then to Preferences, and then set the paths to the database for Odyssian Void and your saves folder before you can do anything else, because this will rely on the settings. The settings are actually built into the properties of the application, so it's not like a thing that's saved somewhere. It's actually in the application, and the internal C# code will actually create a I think it works using using registry keys to store that information for the application. But it is built-in functionality for C#, how it works. So right now I have this set already. So what we have here now is going to be just our basic query browsing window. So what this is going to be able to do is you're going to be able to look at this and create queries that will bring up various things from individual tables. So say that you want to look at existing data for the settings for, say, the easy, I'll say realistic difficulty, and we'll look at the current values and maybe get the field list so you know what to use on some of the other tables. That's basically what this is going to be for, is to look up existing stuff and check it out and kind of look and see what's there and things like that. There's not going to be any actual editing happening in this one. So what you need to do is, first of all, you have to go to Edit, which will be called something else eventually, and click on one of these two things. So Database Editing Mode will load up the database file, whereas Save File Editing will bring up a file open dialog that you'll need to go and open up a save database directly. It won't load directly into one. It'll ask you to choose one from your save file folder. I don't have anything implemented for that, so we're not going to do that today. For database editing, though, we do have some stuff, so I'll click on this. So initially what it'll do is it'll just load in the table names from the database that you have indicated in your preferences path, and then load the for the table that's first showing up here, which will usually be probably A-plotting unless you're creating a database that's going to have some other name for the armor plating table. So like if you're creating a database for mod apart from the database that OV actually has, it'll bring up this, and these will be alphabetically ordered, by the way. It'll bring up the field list for that table in the order that there are in the table. So this is the field list in the exact order that they are in the database. This right now, I'm just trying to decide how this is going to work. Initially, I thought, well, maybe you could use this, double click on it, and have it add this to somewhere. But then I was thinking, well, I mean, I guess you would have to have some sort of context for that. So, like, if you click on this, and you have to say, well, while this doesn't focus, or when you click on it, set a variable so that this knows where you're supposed to add that to, or something. I don't know. I mean, that's one way we could do it, and it actually sounds like the better way to do it. Some sort of bool or something like that, or a string that says text box focus and equals field list or where conditions or something. So you can double click on these and add them directly into there so you don't have to type them. Failing that, though, I also thought this would be nice to have so you know what the fields actually are and what their what their actual text is, so that you don't have to have the database open while you're trying to create a field list to query something or for editing or something. You can just use this to find that out. So let's go ahead and change our selected table to settings, and we'll just go with that example I just had. So you want to see what's in here for the hard difficulty. No, I said realistic difficulty. So the field list is basically the fields you want to display in the query results. So let's say we don't want to do ID or description or setting error. We just want the setting key and setting value. So let's put this in here: setting key and setting value. That's all you have to do, is comment a limited list. Then down here, where conditions, you want to put in the conditions that you want. So in our case, we want to say you just want to have one condition: setting key, and then we want to do single quotes, and then a %, and then realistic. %close. And then click on Run Query. So, okay, here's the other thing. I wanted to do this later, but if you have some sort of error, it'll display what the error is here. So in this case, there's no such column as setting val. So it's actually value. Alright, here we go. So these are all the settings in the setting table for the difficulty settings that are for the realistic setting difficulty. So you kind of you get to see all these things here now. So let's say you just want to see every setting that's in there. So just take out the work conditions, leave that there if you want to just have those. And now you can load in all the data from the database here. Now let's say that you're an NPC ships and you want to see the name, ship class, and base CXP for ships for NPCs that are that can be a level that can be level 10 to 67. So what we need to do now here is we have to say, okay, name, ship class, and then base CXP. And then the where conditions would be where level range, so level range min is at least, so less than, so I said 10 to 67, no, 10 to 76, so 10, and so, and level RNG max is less than or equal to 76. So here we are. Let's also go ahead and add in the level range as well. And in this case, you can have the things in any order. It doesn't have to be the same order as in the table. Okay. So here are our, and then also let's then say order by level range min. All right. So we have our ships here now, and they are all within this range. So they can they won't be underneath 10, they won't be over 76. And we have their names, the type of ship, and the base CXP for that ship. And that's kind of how this can be used for. It's to look at the existing data and see what's there. Eventually, I will add the ability to we'll have a more advanced version of this on the second tab, which will allow you to do joins. I don't have that completed yet, so on the next time I do recording for the DV, I'll show that to you. That'll be done by then. So you'll be able to do joins on tables. So, for example, let's take what we have here and do a join. Well, it's not. Let's see. No, we can't really do join with this table. Let's take the. Let's use the resources table. So, resources and reprocessing, and we'll do a join here. So, let's say that we want to actually figure out what these are. We don't want to be going back and forth between resources and reprocessing to figure out what these values are representing. So instead, we want to figure out what these values are and actually print out their values from resources. So what we're going to do is we are going to well, let's not say we want to figure out what they're for, basically, is what we want to say. So let's go ahead and go to SQL and then so select everything. Well, no, select so we'll say name so name SG2 type stage 2. Let's do these. Oh crap. Okay, that was kind of a brain fart there. So eventually we'll be able to do this in the modding tool, but just to show you what I mean by a join, and why this would need to be on an advanced version of that query browser. I mean, technically you might be able to do it in the where conditions. Well, no, you couldn't because of how it's structured. The where has to come after the joins, so you couldn't do it there. Okay, that is integer. And base size float. So these are going to be T1. T1 stands for table 1. I just find it easier to use T1, T2, and stuff like that for these instead of actual descriptive names. From resources as T1. Then you want to say inner join reprocessing as T2 on. Of course, I need to add in also our I don't think, well, we don't actually need to do this. So reprocessing on. Let's actually also then add our stuff from reprocessing. So we want to use these. So base size. Oops. Reprocessing unit, so T2 here dot reprocess float T2 dot res produced res cost T2 and then T2 dot from resources on. So on is the condition on which you are combining the tables. So in this case, it's going to be OID and ID. OID from the second table and ID from the first table. So on so T1.ID equals T2.OID. So you will not have any resources in this join. And this should work. Yeah, here we go. So everything is an OR. And you have your values here now. And in some cases, you'll actually see things come up more than once. So in this case, Tremaxyl minor comes up twice because it actually has 2 resources in that ore. Now, what I wanted to do and wasn't sure how to is actually to have a resource field in here that actually had the name of the resource instead of the ID. There's probably a way to do it, but I'm not sure how to do it. I'll have to look that up and show it to you next time inside the tool. But here's like an example of what you would do with this. So let's say that you wanted to check what the reprocessing values were for a particular type of ore, for the ores in general, just to see what they are and want to, because you're wanting to create one or something, a new ore, and you want to check it against what's there. Instead of going from resources to reprocessing, checking the values and making sure everything is correct with it, you create a join. So you basically say, okay, here's the data I'm looking for, these, and then you say, I want to see the data for the records where the primary key or something in one table is the same as an ID or something in another table. Most of the time you'll do it. Most of the time you'll use a primary key and a foreign key. The foreign key being the ID of the primary table that's present in another table. So in database relationships, you have 2 tables, or maybe more tables than 2. One table is the table you have the data from that you're using to look for things. So let's say like with a customer database, you have a customer's account, and you have their orders in another table, and their accounts in one table. So every customer has a unique ID. In the order table, you then have a field called CID or customer ID or something that is the ID of their account record. So you use that ID to look up all the orders that account has done over a particular time or over the lifetime of the account. That's basically the same thing we're using here, just we're using it in a different way. There's no, it's not like for customer orders and things, it's for ores and their values in their processing table. This is basically how you would also then look up information for the cross-references as well, which I showed you in one of the previous developers vlogs. So this is kind of the same thing here, except we just don't have a cross-reference table in between, because it's not 2 tables we're connecting to each other. Well, it's in this case, it's not a situation where we have a particular record that could be used multiple times by different other records. We have a record that has a specific set of values that relates to one other record from another table. So, like for example, the clone effect cross-reference, or rather, let's just say effects and then the effect modifiers. So the effects is defining what the effect is. So in this case, the name, we're just giving it an ID, we're giving it a name and a description. What we're doing then in the cross-reference is saying, okay, in cross-reference modifiers, we're saying, or in effect modifiers, we're saying that here are the effects, the modifiers for effects, and here's what they do. So we have this effect, we're saying it does armor damage, and it increases the armor damage by 25%. Now we're saying that anything over here can use that, and so in order to encapsulate that without having to do multiple records of this particular effect to allow other ones to do it. So like if we have, let's say we're just doing this as 2 tables, the effects in this, and we're just linking them together through this ID field here. What would happen then is you would have, let's say we have 3 or 4 effects that do 25% increased damage to armor. You would have to have 3 or 4 of these individual records duplicated, because each one would only go to one effect, because these are all singular IDs. So let's say like you have 3 effects in here somewhere, so like 1, 5, and 8, assuming they're not what they are now. All use this effect modifier of armor damage plus 25%. since you would have this ID and then one other another ID field for the effect ID over here, you would have to have one for each one. Since we have this in between, we can say, okay, all three of those use this same record and effects modifiers, so you don't have to create it a bunch of times. That's not what's happening down here, though. Down here, it's a 1-to-1 kind of thing, or maybe a 2-to-1 if there's an OR that has two different resources. So this kind of simulates what happens up here. What would happen up here if we did the same thing without the cross-reference table? We'd have these two. We'd have two of these or three of these kind of fields for one particular type of damage if multiple things were using it. Here we're saying this is for trimaxil for rubies and plutonium on the resources. So that's kind of what this allows you to do, just much more easily. And this will be like what you can do in the advanced version of this query browser. And that's really all you can do with this right now. That's 2 days worth of work. Well, not even 2 days. It's 13 hours total worth of work here. So it's not too much time put into it, but it's already kind of shaping up to be what it's going to be. So that's this. Just wanted to kind of show you where this is going at. And this is fully into the database. There's no other files to modify. In the previous version of this, there was also an INI editor as well. Don't need it now because it's all in the database, so that's all there is. So that's one thing I wanted to show you. Next, I'm going to show you something else. It's kind of another tool that you can use to deal with creating new enemies and things, and also new randomly spawned enemies, and also when you're modifying certain CXP settings in the database. You can use these to do that, but you'll also be able to see the effects of that stuff in the tool as well. There's just a different way of seeing that data visualized. So have this OVEXP calcs. This will be called something else eventually. So what this is an Excel sheet that's essentially what it's showing you is EXP curves. So in this case, this is showing you EXP growth curves. So this is representing the growth of the amount of experience needed to get to each level as you're going through it. So as you can see, at level 1, we don't need very much. At level 10, we need more. So, it's a certain amount there. And this keeps going up and up. And you can kind of see the actual value representation over here. This would be more like this, except the starting point is at this instead of down here at 0. Or rather, it's at 0 instead of up here. That's the problem. And the ending value is up here instead of closer to the bottom. So this would be more this kind of shape otherwise. But so what I have here is essentially a value calculation from a custom function that I wrote in here. Alt F11 called getCXP. So you're passing in the base value, the level, and the factor, and then you're using them in this logarithmic function to produce a value that will be CXP value that will allow you to have like a curve like that instead of being straight like the currently existing EXP generation code is from the old code. That's basically a straight line up. There was no curving. There was no adjustment as levels went up to make it so it was harder to get to the next levels. It was just basically a straight line. You would always need the same amount of experience, or about plus or minus a couple hundred CXP to get to the next level from where you're at. With this, it makes it go more on a slope, so the leveling difficulty gets harder as you go up. So on this one, I have it up to level 200, though that's not the max. I don't have the charts all the way down there yet, but as you can see here, to get to level 200 on the current settings here, which are representative of the easy settings on that are in the database. So 2.11 on the factor, 2.12 on the factor, and 96 on the base. Those are the easy difficulty, or no, moderate difficulty settings. Is it moderate or easy? Well, let's go find out. Moderate. It's moderate. Okay. Oh, it even says moderate down there. Duh. So yeah. So if you're playing on moderate, this is what your EXP growth will look like. So as you increase in levels, you'll be needing to have more and more and more. Let's see if there's actually like some sort of pattern here. There probably is, but we'll just take a look here. So equals D2 minus D3 minus D2. I think this will be interesting to see if there's some sort of... So no, there isn't really a pattern. It increases by a certain amount every time, but it doesn't seem to be a pattern. There's like 200. So this is let's see, 8, 4, 284. Yeah, so that's not 284. That's 196, I guess. So it is different for each one of these. It's not like an equalized number between them. It's a random number. Let's do the same thing down here and see what we get. So equals D219 minus D218. Again, doesn't seem to be any real pattern that I can discern. I bet if I actually minus this out far enough, you probably would find a pattern of some sort, but I'm not going to do that. So like what I mean by that is then you have this, so then you say equals E 219. And you can kind of see a pattern right there, actually. So it kind of flips back and forth between various values as it's going up, but it increases by 1 every once in a while. And I bet then you can see that much more probably if you then went another level down. So equals F 219 minus F 218. So you kind of see it increases and decreases, decreases variably. Sometimes there's no difference. So there is somewhat of a predictability to it, but at the same time, I bet you anything if you did it through the whole thing, you would see that it does do this, but we're also increasing constantly, and so we have a different kind of increase in value. That causes this curve to happen. But the other half of this is, though, or the other part of this, there's going to be one of these tabs for every difficulty settings for the CXP stuff. But the other part of it is enemy CXP rewards. So on this one, it's more of just like looking at what you get for the rewards and looking at the level that they are and seeing how many you would need for a particular level. So we have, this is basically the data straight out of the database. So we have our different various types of main enemies up here for the Hellfang group. Then I break it up by level. So the Hellfang Raider can be from level 1 to 16. So I have a basically a calculation on that EXP that you get from that ship based on its level. So level 1 to 16, you can kind of see it's mostly just kind of a straight line on this one because it doesn't go far enough on the settings over here. I don't think to have a curve really on it, but it kind of gives you an idea of what you get per level. So gives you a better idea of how your stuff affects what's going on. So like for example, let's make the base equal C1, or rather C2, my mistake. Let me just drag this down. Crap.